In today's lesson over conic sections, we're going to talk about parabolas, and you've probably seen a parabola at this point, but we're going to talk about it in the conic section world, where not every parabola that you see is a function. Okay, you're going to have parabolas that open up, that open down, but also may open left or right. So the definition of a parabola here is the set of all points that are the same distance from a fixed point, called a focus, and a fixed line, which is called a directrix. So let's label parts of this parabola here. I have a parabola. I've got a bunch of dots on here, some dotted lines, and a solid line. So I'm going to first point out this point right here, which you probably would be able to label. That's the vertex. Okay, but the vertex, if I'm going off of this definition, the parabola is a set of all points that are the same distance from a fixed point and a fixed line. Well, this line right here, we're going to call this the directrix. The directrix. The directrix. And this point right here, we're going to call this the focus. This vertex right here has a distance of p units from the directrix and a distance of p units from the focus. And as a matter of fact, every point on this line, every point on this parabola is the same distance from the focus as it is from the directrix. Okay, so let's move on and let's label some other parts of this parabola. So we have 2 points. I've got 2 points that are in pink right here that are on this parabola, and I've just colored them in orange, but that's in orange, so I'm actually going to change this. So we have 2 points that are on this parabola, okay, and these points are perpendicular to this line that connects the focus all the way to the directrix. The distance from that focus to the point on this parabola has a distance of 2p. It's also 2p from this other point on the parabola. Okay, they're the same distance. And that entire line right there, I'm going to do this color right here, that entire length is called the latus rectum. And it has a distance of 4p. So those are all of the parts of the parabola that you'll need to know today. We're talking about the vertex, we're talking about the directrix, the focus, the latus rectum, which has a length of 4p. But a big thing right here is, what is p? The absolute value of p is the distance between the vertex and the focus. It is also the distance between the vertex and the directrix. So that's going to be important as we're working through problems today. Now, when we're graphing parabolas, you can have a parabola that opens horizontally, which, if that's the case, let's draw our little coordinate plane here, okay? And let's draw a vertex right here, okay, at the origin. If your parabola opens horizontally, it might look something like this, okay? It could obviously open the other way, but if it opens horizontally, it's going to look like that. Now, if it opens horizontally, the directrix is going to be a vertical line. And the focus is going to be to the right of the vertex. Now let's talk about, what is p? The distance from that vertex to that focus is p, and the distance from that directrix to the vertex is also p. And the equation for the directrix, because it's a vertical line, is going to be x equals -p. Now, some key points to remember, and you'll probably, as we're working through the problems today, you might want to refer back to these particular notes right here. But if p is positive, your parabola is going to open right. And if p is negative in your equation, your parabola is going to open left. The equation for your directrix is going to be x equals -p, and that's going to be a vertical directrix. So let's label this other one over here. What if you have a parabola that opens vertically? In this case, which I didn't really point it out on the other one, so I'm going to shift gears back over here. If it opens horizontally, guess what's squared? The y is what is squared. If it opens vertically, guess what's squared? The x is open squared, and I only have one squared variable. I don't have an x squared and a y squared. I just have one squared variable. If your parabola opens vertically, I'm going to draw my coordinate plane here, and I'm going to draw a vertex at the center. And if it opens vertically, it might look something like this. It could open down as well, but this is probably what you're used to. And in this case, you have a center point, you have a focus that might be somewhere right there, and a directrix that might be somewhere down here. And in this case, your directrix is a horizontal line. And again, the focus has a distance of p units from your vertex, and the directrix has a distance of p units from the center. The equation for the directrix is going to be y equals, because it's a horizontal line, negative p. Now in this case, if p is positive, your parabola is going to open up, and if p is negative, your parabola is going to open down, and y equals negative p shows you that you have a horizontal directrix. So again, these are just quick notes that you might want to refer to as we're working through the problems today. So let's move on to graphing parabolas. Oh, and here I actually have them already labeled. All right, steps to graph parabolas. So if this is the first time you're watching this because you only need to know conic sections with parabolas, then you haven't watched any of the other videos that I've talked about when I've talked about circles, hyperbolas, ellipses. But this is meant to be the last lesson in this particular unit, but for some of you it might just be the first lesson. So when you're graphing parabolas, the first thing that I want you to look for when you're given an equation is to choose the appropriate graph type. Will it open horizontally or vertically? And I like to draw a little sketch. Then determine if it will open up, down, left, or right. So let's look at example number 1. I have x squared equals negative 8y. In this case, I have a x that is squared. Okay, so my x variable is what is squared, not my y variable, which means this is going to open vertically. So let's write that down. It's x squared, so it opens vertically. Now we need to determine if this is going to open up or if it's going to open down. And we only just touched on this on the notes on the other page, but if p is positive, it's going to open up, and if p is negative, it opens down. Right here, this right here is 4p, which we didn't really look at the equation, but I'll write that equation down as we're working through it. Because that is a negative p is negative, it's going to open down, okay? So I'm going to draw a little picture, all right? Your parabola is going to open down. The equation that you might want to refer to from the other page is x squared equals 4py, okay? This is the equation when your parabola opens vertically, okay? And obviously, if I want to do any kind of translations, I'm going to have, in parentheses, I'm going to have x minus h squared equals 4py minus k, okay? And my center point is going to be, or my vertex is going to be at hk. So let's see what we got here. So I know that it opens vertically, and I know it opens down. Because we don't have any translations, when you think about all your translations for your different functions that you've probably talked about, or if this is, the fourth lesson in this unit that you've watched all my other videos, you know that your vertex is going to be at HK. And it's going to be like the opposite of what's on the inside, right? Because it affects it by x minus h and y minus k. In this case, we don't have anything like that. We don't have anything in parentheses, so the vertex is just going to be at 0, 0. And let's go ahead and graph that. So now let's find the value of p. I know that p right here, 4p is in front of y. The number in front of y is -8. So I can write an equation setting 4p equal to -8. And if I solve for p, I'm going to divide both sides by 4. So I get -8 divided by 4 is -2. And obviously, I'm going to have a negative because I have a negative right there, right? The 8 is negative, so -2. So I know it's opening down, but I know that the focus and the directrix are going to be 2 units from that vertex. So 2 units up, I'm going to put a dot. 2 units down, I'm going to put a dot. The one down, that's my vertex. Because this parabola is, not my vertex, that's my focus. Because this parabola is going to open down. 2 units up, that's the directrix. Okay? That's where the directrix is going to be. So let's label this. The focus, the ordered pair is 0, -2. And the directrix is going to be y equals +2. That's the equation of the directrix. Now let's go ahead and graph the rest of this parabola. I can graph 2 additional points on this parabola because I know that from the focus out to the right is going to be a distance of 2p. If I know p is 2, I'm going to go out 2 and 2 more. It's going to be double. Out 2 and 2 more to the left as well. So I have graphed 2 additional points for this parabola. I can connect those, and that's how I'm going to graph that. Okay? Let's move on to the next one. I'm trying to explain this as if I haven't just done lessons over circles, ellipses, hyperbolas, and I'm trying to not assume that you know all of that information because you may just only be looking at parabolas if you're in a certain state that only covers parabolas. So in example number 2, let's first focus on how is this parabola going to open? Is it going to open vertically or horizontally? Since the y is squared, I know that it's going to open horizontally. So y is squared, whoops, it's not really. Y is squared, so it opens horizontally. So now which way is it going to open? Is it going to open to the right or is it going to open to the left? If p is positive, it opens right. If p is negative, it opens left. So I'm going to look right here. And I can see that p is positive. Now that's 4p, right? 12 is actually 4 times p, but I know that it's positive, so p is not going to be negative. So p is positive, so it opens right. I don't know why I wrote an S there. So it opens right. And I'm going to write that down. So now where's the vertex? So the equation that you would use for this particular problem would be if it opens horizontally, y squared equals 4px, right? If you look at your notes on the previous page, that's what it is. So our vertex, we're not translating our vertex horizontally, but we are translating it vertically. Remember, this is y minus k squared, which means my k value is going to be -3. So my vertex is going to be, I'm not translating it horizontally, I am translating it down 3 units. So it's like the opposite of what you're seeing. Okay, so 0, -3, 1, 2, 3, that's the vertex. So now let's find the value of p. I'm going to take what's in front of the x term, what is not squared, and I'm going to set it equal to 4p, right? That's in front of the x, so 4p is going to equal 12. I solve for the value of p, which is 3. P is 3, which means I'm going to go out 1, 2, 3 to the right and out 1, 2, 3 to the left. Because this parabola is going to open to the right, I know that the focus is what is here. That's the focus, which means the directrix is here. And because it opens horizontally, that directrix is a vertical line with the equation x equals -3. Okay? So the equation is x equals -3, and the ordered pair for the focus is +3, -3. And now let's graph some other points on this parabola. I know if p is 3, from that focus, I can go out double p, right? So 2p is 2 times 3, which is 6. So I can go 6 units out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I've graphed 2 additional points for this parabola, and it's going to open just like that. And that's how we would graph that parabola. Let's move on to our last example over graphing parabolas. In this example, y minus 2 squared equals -2 times x plus 1. So I only have one squared term, or one squared variable, so I know it's a parabola. Is it going to open horizontally or vertically? Because y is squared, I know it opens horizontally. Now, what do I look for to tell me if it opens up, or I'm sorry, right or left? I'll look at the value of p. And in this case, right here, p is negative, so it opens left. So let's write that down. It opens left. Now, in this case, we do have some translations from our center. Okay? X plus 1, y minus 2. Our vertex is going to be, because it affects it, x minus h and y minus k, I'm looking at the opposite of what's inside there. That's what your brain is going to do. So x plus 1, because it affects it by x minus h, I know that h must be -1 to get x plus 1. That's how I'm getting that. So I know the vertex is at -1. The opposite of -2, right? That's going to be +2. So the vertex is at -1 and then up 2, right there. So now let's determine the value of p. The value of p is going to be right here. Remember that we're going to set that number equal to 4p. We're going to set it equal to the length of the lattice rectum. When I divide both sides by 4, I get p equals -2/4, which is -1/2. And that's the value of p, -1/2, which means, and I'm going to zoom in here, I know it opens left, but from that vertex, I'm going to go to the left 1/2, and I'm going to go to the right 1/2. Because it opens left, I know that the directrix is going to be this line right here, which is, x equals -1/2. That's the equation for that line, right? It's a vertical line, and that's at x equals -1/2. And the focus is 1/2 of a unit to the left. Because it opens left, that's where the focus is. The focus is like inside that sideways parabola. So the focus is going to be -1/2 and then up 2. Or I could say that as -3/2 up 2, right? Because -1/2 is the same thing as -3/2. So however you want to write that. Now let's graph some additional points. I know that that lattice rectum has a length of 2p, which is 2 times 1/2, which is 1. So from that point right there, I can go down 1 unit and up 1 unit, and I've graphed 2 additional points on this parabola. I can connect those points, and I've got that sideways parabola. So let's move on to writing some equations of parabolas. And we only have 2 more examples in today's notes, so I'm going to try to get through them very quickly because I've already taken 20 minutes to explain this. So when you're writing equations of parabolas, the first thing you need to do is choose the appropriate form of the equation. Which way does the parabola open? Up, down, left, right. You need to identify the vertex, find the value of p, and write the equation. So in example number 4, it says to write the equation of the parabola that opens right and has a vertex of 4, 2. If it opens right, that means y is squared and p is positive, right? If it's opening right, if it were opening left, it'd be y squared, p would be negative. If it would be opening up, it'd be x squared, p is positive. If it opens down, it'd be x squared and p is negative. But it opens right. So that's all the information I can gather from that right there. And then the vertex is at 4, 2. Well, that's HK. The distance from the vertex to the directrix is 3. Well, I know that to be the value of p. So let's write this equation, okay? I know that y is going to be squared, and I have a k value of 2, positive 2. So I'm going to write y minus 2 squared, right? Because it's y minus k. Equals, now in here, I'm going to have 4p, right? The lattice rectum right there. And then over here, I'm going to have x minus 4. Because I'm putting in my horizontal translation, which is the opposite of what you're given right there, right? Because it's going to affect it by x minus h. So now, in here, I'm going to put the value of 4 times p. Well, what is 4p? I know p to be 3. 4 times 3 is 12. So I can rewrite this equation as y minus 2 squared equals 12 times x minus 4. And that's the equation for that parabola. Let's move on to the next one. This is the last one. This one says to write the equation of the parabola that has a vertex of -3, -5. Okay, that's HK. And a focus at -3, -7. Okay, well, let's think about this. -3, -5, 1, 2, 3, -1, 2, 3, 4, 5, that's right there. If that's the vertex, and -3, -7 is the focus, then this is going to open down, right? Because the focus is like inside that parabola. It opens down, so I know I'm going to have x squared. And what else do I know? I know that p is negative. I also know that p is from -5 to -7, which has a distance of 2, which means p is -2. Did I do that too fast? I know this distance right here from -5 down to -7 has a length of 2 units. I know p is negative, so it's got to be -2. So let's write this equation. If I'm writing the equation, I know x is what is squared, so x plus 3 squared. You see how I did that? H is -3, so it's x plus 3 squared equals, I'm going to put something right here, and I'm going to do y plus 5. If y is -5, it's going to be y plus 5. Inside that box that I drew, I'm going to put what 4p is, right? Because that's the lattice rectum that you put right there. So 4p is 4 times -2, which is -8. So I can rewrite this as x plus 3 squared equals -8 times y plus 5. And that concludes your notes over parabolas in conic sections, and I hope it was helpful.